Today's topic is Michelson-Morley experiment. First, we will see what is the need of Michelson-Morley experiment. According to Maxwell's electromagnetic theory, speed of light in vacuum is c equal to 3 into 10 to the power 8 meter per second in all the directions. As speed is a relative quantity, the question arises that relative to which frame of reference the speed of light is c. An inertial frame of reference in which the speed of light is equal to c in all directions is called the absolute frame of reference or preferred frame of reference. Frame of reference is used to find the position of a point. For this, three mutually perpendicular axes, x-axis, y-axis and z-axis are used. These three mutually perpendicular axes meet to a point known as origin. So, frame of reference is nothing but these three mutually perpendicular axes, and inertial frame of reference is one in which law of inertia is obeyed. Law of inertia is this, that when force acting on a particle is 0, its acceleration is 0 and velocity remains constant. So, speed of light in vacuum, we write it by c and its value is 3 into 10 to the power 8 meter per second. Now, in which frame this speed of light is c? This frame was called absolute frame of reference or preferred frame of reference. A medium is required for the propagation of mechanical wave, and by comparing with mechanical waves, it was assumed that a medium is also required for the propagation of light wave. Such a medium was assumed necessary for the propagation of light wave. This imaginary medium surrounding the earth was given the name ether. So, it was assumed that a medium is required for the propagation of light wave. By comparing mechanical waves for which some medium was required to propagate, and around earth this medium was given the name ether. So, it was assumed that ether medium is around the earth, and in this medium speed of light is c in all the directions. So, this ether medium was assumed as absolute frame of reference in which speed of light is c in all the directions. It was assumed that in this medium speed of light is c in all the directions. So ether was assumed as absolute frame of reference. By assuming imaginary medium ether as absolute frame, Michelson and Morley performed an experiment to find the speed of Earth relative to ether, which is known as ether drift. So ether drift is speed of Earth with respect to ether medium. And Michelson-Morley experiment was performed to determine this ether drift, that is to determine speed of Earth with respect to this ether medium, which was assumed as absolute frame, in which speed of light is c in all the directions. Experimental arrangement of Michelson-Morley experiment is shown in this figure. S is source of monochromatic light having particular wavelength lambda. So S is a source of monochromatic light having a fixed wavelength lambda, and light from this source S is allowed to fall on a plate P. P is a glass plate which is placed in such a position that it makes an angle of 45 degree with the vertical. And when light from source S falls on this plate, on first surface this light is refracted and reach to its lower surface, and this lower surface is partially polished by silver. Since lower surface is partially polished by silver, so by this surface this light ray will be partially reflected and partially refracted. So this single ray will divide into two rays. One is reflected and goes towards mirror M1. Other is refracted and it goes towards another mirror M2. Experimental arrangement of Michelson-Morley experiment is shown in this figure. Light from a monochromatic source S is allowed to fall on a glass plate P, which is kept inclined at an angle of 45 degree with the horizontal. One surface of glass plate is partially silvered. So in this diagram, this lower surface where P is written, this is partially silvered. The light incident on the plate P is partially reflected and it goes towards a plane mirror M1, and remaining part is transmitted, which is refracted, and it is transmitted towards the plane mirror M2. M1 and M2, these are two perfectly reflecting mirrors which are kept mutually perpendicular to each other at some distance L from plate P. Distances of these two mirrors M1 and M2 are same. Distances from plate P, distances of mirror M1 and mirror M2 from glass plate P are same, and it is assumed as equal to L. And these mirrors M1 and M2 are placed mutually perpendicular to each other. The light after reflection from the mirrors M1 and M2 reunite at the plate P and moves together in the same direction as shown in figure. When this light ray is divided into two parts at point P of glass plate P, one part goes towards mirror M1 and then it reflects and comes back to this point P. Similarly, the transmitted part or refracted part of this ray goes towards mirror M2, and after reflection from this mirror M2, it again comes at point P. So at point P, the ray coming from source S is divided into two rays, and these two rays after reflection from mirrors M1 and M2 reunite at point P of this glass plate P. And then these two rays moves in the same direction, and interference phenomena took place, and interference fringes are seen by this telescope T. Due to superposition of these two light waves, interference fringes are formed. These interference fringes are seen by means of a telescope T. Reflected ray PM1 passes through glass plate P 2 times before superposition. Look at the glass plate P. At point P, the ray coming from source S is divided into two rays. One ray which goes towards mirror M1, it travels a distance equal to width of this glass plate P 2 times when it goes towards M1, and when it comes after reflection from M1. So the ray which is reflected at P before superposition, it travels in this glass plate 2 times. But the ray which goes towards mirror M2, it will not pass in glass medium before superposition. So we put another plate parallel to this glass plate as shown in this figure in the path of the ray which moves towards mirror M2. So this another plate is placed having same thickness, same medium as glass plate P, and these are parallel to each other. This plate is known as compensating plate. It is used to make the path of both rays, both reflected rays and transmitted rays, equal in glass medium. Reflected ray PM1 passes through glass plate P 2 times before superposition, and transmitted ray PM2 do not passes through glass plate. To make the path of both rays equal in glass medium, another glass plate C of same material and same thickness is placed parallel to plate P along the path of ray M2. This plate C is known as compensating plate. The apparatus is kept inside a vessel containing mercury so that the apparatus can be easily rotated to change its direction. So this was the experimental arrangement. Now we see the theory. The Earth is rotating around the Sun with orbital velocity v. If ether medium is pervading in all space and assumed as absolute frame of reference, velocity of Earth and the entire apparatus relative to ether will be v. Let Earth is moving with orbital velocity v around Sun. Ether medium is assumed surrounding Earth. So the Earth and this entire apparatus is now moving with velocity v with respect to ether, which we called absolute frame, in which speed of light is c. Let direction of v vector is along the direction of PM2. Direction of v vector is shown in this figure. Here it is assumed that direction of v vector is in the direction of PM2. So Earth is moving and this entire apparatus is moving in this direction, in the direction of PM2 with velocity v. V is the velocity of Earth with respect to ether. Ether medium is surrounded around Earth. According to Galilean law of addition of velocity, velocity of light from P to M2 will be c minus v, because direction of v vector is along the direction of velocity of light. For ray PM2, for light wave which is moving from P towards mirror M2, speed of light c is in the direction of this speed v vector. So speed of light now will be c minus v. When two speeds are in same direction, relative speed will be subtracted, and when two speeds are in opposite directions, relative speed is added. So for PM2, ray, speed of light will be c minus v. And when this light is reflected from mirror M2 and goes back towards plate P, then for this reflected light, speed will becomes c plus v, because now speed of light is in opposite direction of v vector. So we can find out the time taken by this transmitted ray from P to M2 and M2 to P. This time we write by T1, and this time T1 will be equal to L upon C minus V plus L upon C plus V. This time is determined by using the formula time equal to distance upon speed. Speed equal to distance upon time. So time equal to distance upon speed. Distance is L. L is the distance between P and M2. So time taken by ray from P to M2 is this time L upon C minus V, and the time taken by ray from M2 to P, this time will be L upon C plus V. So speed of light is C minus V and C plus V. So time taken by light, transmitted light from glass plate P to mirror M2 and back from mirror M2 to glass plate P, this total time T1 is L upon C minus V plus L upon C plus V. L is common, C minus V and C plus V. C minus V into C plus V is taken as LCM. So in numerator we have L into C plus V plus C minus V. L is common, plus V and minus V is cancelled. So in numerator, in bracket we have 2C. So this will become equal to 2LC upon C square minus V square. In denominator we take C square common. So with C square in denominator we have 1 minus V square upon C square. 1 C is cancelled out in numerator and denominator, and we have this time T1 equal to 2L upon C into 1 minus V square upon C square to the power minus 1. Now by using binomial expansion, 1 minus x to the power n equal to 1 minus nx plus we have several other terms, but since V square is much less than C square, so other higher order terms can be neglected and we use only the two terms. The two terms in this expansion are 1 minus x to the power n equal to 1 minus nx. So this term 1 minus V square upon C square to the power minus 1 will become equal to 1 plus V square upon C square. And time T1 will now becomes equal to 2L upon C into 1 plus V square upon C square. So this is the time T1. Now we find the time of this reflected ray which goes towards mirror M1. So time taken by this reflected ray from P to mirror M1 and then from M1 to plate P. We write this time by T2. Then its half time, T2 by 2 time is taken by this ray, by this reflected ray to go from glass plate P to mirror M1. But the entire apparatus now is moving with the speed v in the direction as shown in this figure along the direction of PM2. So when this reflected ray from glass plate P reaches to mirror M1, this mirror M1 will move to some new position which shown in this figure. This new position of mirror M1 is shown by M1 dash. So when this reflected ray from plate P reaches to mirror M1, the new position of mirror M1 will be shown by this figure by M1 dash, and this distance traveled by this mirror M1, now this distance M1 dash will be equal to V T2 by 2 as shown in this figure. This is the distance V T2 by 2. T2 by 2 is time and V is the speed by which this mirror M1 is moving. So distance from M1 to M1 dash is V T2 by 2, velocity into time. But the distance traveled by light from P to M1 dash is C T2 by 2. Time is same, T2 by 2, but now speed is C for light. So these two distances are shown in this diagram, V T2 by 2 and C T2 by 2. And this distance from glass plate P to mirror M1 is L. This is also shown in this diagram. Now it is right angle triangle, and we use the formula that hypotenuse square equal to base square plus perpendicular square. So we have C T2 by 2 whole square equal to V T2 by 2 whole square plus L square. So we write this equation: C T2 by 2 whole square equal to V T2 by 2 whole square plus L square, and by using this equation we find the time T2. This square is C square T2 square upon 4, and V square T2 square by 4 is bring to left hand side. So we get this relation C square T2 square upon 4 minus V square T2 square upon 4 equal to L square. And from this equation we find T2 square equal to 4 L square upon C square into 1 minus V square upon C square to the power minus half. So in this left hand side, C square T2 square by 4 minus V square T2 square by 4, we take this common, C square T2 by 4. The first term, we take this first term entirely as common. Then inside the bracket we have 1 minus V square upon C square. T2 square upon 4 is already common, but we take C square T2 square by 4 common. Then in bracket we have 1 minus V square upon C square, and it is equal to L square. This gives the value of T2 square. T2 square equal to 4L square upon C square into 1 minus V square upon C square to the power minus 1. And if we take square root of this equation, this will give the value of T2. So T2 will be equal to 2L upon C into 1 minus v square upon c square to the power minus half. And now we use binomial expansion. 1 minus x to the power n equal to 1 minus nx. N is now minus half. So it becomes equal to T2 becomes equal to 2L upon C into 1 plus V square upon 2C square. So these are the two times T2 and T1. T2 is equal to 2L upon C into 1 plus V square upon 2C square. And T1 was this time 2L upon C into 1 plus V square upon C square. These are the two times T1 and T2. For these two rays reflected from glass plate P and transmitted from this glass plate P. So, and distance is same, both travel distance L, but times are different. Difference is in the second term inside the bracket. In expression for T1, we have this second term inside the bracket is V square upon C square, while in expression for T2, this second term is V square upon 2C square. Since V square upon C square is greater than V square upon 2C square, we see that time T1 is greater than time T2. So we find the difference in these two times, and we write this difference of two times equal to delta T. So delta T, difference in time, equal to T1 minus T2. This is the time T1, 2L upon C into 1 plus V square upon C square, and minus this is the time T2. If we solve the bracket, the first term 2L upon C is cancelled by minus 2L upon C, and the remaining two terms will becomes equal to LV square upon C cube. So difference in time delta T comes equal to LV square upon C cube. Now path difference is obtained by multiplying by c, speed of light. Delta T is difference of time, and if difference of time is multiplied by speed c, this will be path difference, because distance is speed into time. So difference in distances, which is path difference, will be equal to c into delta T. So if we multiply by c to delta T, this will becomes equal to LV square upon C square. Delta T is LV square upon C cube. If we multiply it by C, this will become LV square upon C square, and it is the path difference. Now the entire apparatus is rotated by 90 degree, so that the direction of Earth's velocity v vector becomes along the direction of Pm1. It will produce the same path difference but in the opposite direction, and net path difference will becomes 2 times. So by rotating the entire apparatus by 90 degree, the path difference must be 2 times, so it will become 2LV square upon C square. Initially path difference was LV square upon C square, and when entire apparatus is rotated by 90 degree, this path difference will becomes 2 times. So now path difference is 2LV square upon C square. Due to this path difference, some fringes should be shift. If n fringes shifts due to this path difference, this path difference must be equal to n lambda. When one fringe shift, path difference will be lambda. When n fringes shift, this path difference will be equal to n lambda. So if we assume that n fringes are shift, then this path difference must be equal to n lambda. Put this path difference equal to n lambda. we get this relation 2L V square upon C square equal to n lambda, and this will gives the value of n equal to 2L V square upon C square lambda. This is the number of fringes which are shifted. In Michelson-Morley experiment, distance of plate P from mirror M1 or M2 is made 11 meter effectively. So distance L is 11 meter in this formula. Orbital velocity of Earth is V is 3 into 10 to the power 4 meter per second. Speed of light C is 3 into 10 to the power 8 meter per second. And wavelength for yellow light is lambda equal to 5800 angstrom, which is 5800 into 10 to the power minus 10 meter. It is not 10 to the power 10 meter, it is 10 to the power minus 10 meter. Substituting all these values in this relation, we find n equal to 0.4. So the fringes shifted will be 0.4 of a fringe. It is less than one fringe. So 0.4 fringes should be shifted. Negative result of Michelson-Morley experiment. Theoretically, there must be shift of fringes equal to 0.4 times fringe width when the apparatus is turned by 90 degree, but experimentally no fringe shift was observed. Now, it was assumed that if orbital velocity of the Earth VE with respect to Sun and velocity of absolute frame, that is ether, we write this velocity of absolute frame by VAB with respect to Sun. If we assume that these two velocities are equal and in same direction as shown in this figure, the Earth is shown moving around the Sun S. VE is Earth velocity, its direction is shown by this arrow. Ether is between Earth and Sun. Let this ether frame, which is absolute frame, is moving with velocity VAB, AB for absolute. So VAB is velocity of absolute frame and VE is velocity of Earth. If we assume that these two velocities are same and in same direction with respect to Sun, then velocity of Earth with respect to ether, V will becomes equal to VE minus VAB, and VE and VAB are equal, then this V will becomes equal to 0. So if Earth and absolute frame ether both have same velocity and in same direction, the relative velocity V will become equal to 0. And if V becomes equal to 0, then from this formula we have n equal to 0. So because n is found equal to 0, because no fringe shift was observed, n is 0, we can explain this by assuming that this velocity V is 0 and this velocity V can become 0 in this way when Earth velocity and absolute frame velocity are same and in same direction. But if this experiment was repeated after 6 months, then after 6 months velocity of Earth VE is now in this position, in this direction. VAB, direction of VAB is same as previously, but after 6 months direction of velocity VE is in opposite direction, and if we now assume that these two velocities are same, then relative velocity must be equal to VE plus VAB, and if two velocities are same, then this must be equal to 2VE. If we put VAB equal to VE, then this will becomes equal to 2VE, now 2 times. So after 6 months, this relative velocity will be 2 times. If we put 2V in place of V, then N should be 4 times. We have the factor V square, and if we write 2V in place of V, we get 4V square. So N must be 4 times. So 4 times fringe displacement should be observed. But when this experiment was observed after 6 months, then also no fringe shift was observed. This is called the negative result of Michelson-Morley experiment. No fringe shift was observed by Michelson and Morley even when the experiment was repeated after 6 months. This was called the negative result of Michelson-Morley experiment. Now, conclusion. From the negative result of Michelson-Morley experiment, it was concluded that the velocity of Earth relative to absolute frame ether is 0, or we can say that negative result of Michelson-Morley experiment is against the ether hypothesis. Einstein developed a new theory by rejecting the concept of ether hypothesis and absolute velocity, according to which only relative velocity is of physical significance. With this, Einstein also assumed that the velocity of light in vacuum is constant in all directions, and it do not depend on the motion of source and observer. So from the negative result of Michelson-Morley experiment, Einstein rejected the concept of absolute frame, or he rejected the concept of absolute velocity, and he said that relative velocity is of physical significance only. And with this, Einstein also assumed that speed of light c is constant in all the directions, and it do not depend on motion of light source, or on the motion of observer. Speed of light is c. It is not affected by the motion of light source or by the motion of observer. And by this concept, he developed the theory of special relativity.